This is the 9th video in the beginning programming series about Octagon, and in this video we're going to learn about tasks. For more information, visit jb.works and at the search prompt enter the TMT code at the bottom of the screen. So the first thing we're going to look at is what actually is a task. Tasks basically let you group useful code together and let you reuse it so you don't have to keep on typing it all the time. And they can be called pretty much from anywhere inside a program. And they also have the effect of making programs easier to read for human beings, because ultimately you're writing the program for a computer, but a human being has to be able to understand it as well. So you've actually come across tasks before, because if you think back to the video where we did the first program, the wee program that we did, which basically just printed hello world right here, it has tasks. The first task it has is one called prog_start, and you can see tasks start with a name followed by a space, then the equals character, and then they're all terminated by the same name and a full stop. So it's a bit like the English language. You end a sentence with a full stop. And then all the code that goes between the start and the finish is the code that the task runs. So whenever I call that task, it'll always run this code. And then when it gets to the end, it will just exit and do the next thing. And likewise down here, we've got the prog_stop task. And that just runs this wee code, which says goodbye, and then it stops. So these are tasks. So far, we've only looked at system tasks. Now, system tasks are tasks that belong to Octagon and are used by Octagon. And they are things like the prog_vars task here, which is where you declare global variables, the prog_start task, which is where you basically put code that you want to have run at the beginning of your program, and likewise the prog_loop, which holds code that will just run continuously while the program's operating, and then finally prog_stop. So these are all called system tasks because they're tasks that belong to Octagon. And one other thing to keep in mind about system tasks is that you can't call them in your programs. They are just always there and Octagon will deal with them. So you can't call these like you would normal tasks. So user tasks are tasks that can be created by the user, which is the person running the program. And you can't have user tasks with the same names as system tasks because that would just be very confusing. And so you need to declare your user tasks. Whereas you don't have to declare the system task because they're just always there. So in this little program here, we've got the normal system tasks, prog_loop here. But then here's a new task. This is the flash user LED task, and that's a user task. And it basically just flashes the user LEDs all on and then all off. And here is the terminator for it. So it's simply the name of the task with a full stop after it. So your user task starts off with the name of the task, a space, and the equals character. You put your code inside here, and then you put the name of the task followed by a full stop. And the user task has to go before the prog_stop task, because the prog_stop task is always at the bottom because it's the last thing that is run by a program. So let's go to the editor and have a closer look. Okay, so we're in the program editor, and I've got this pretty boring program. So basically if I run it, all it does is print program start, program loop, and bye. So it's program start, it's program loop, so it's in the main program loop. Now this is something we haven't looked at yet, and that is the exit prog command. And what that does is whenever it's run, it basically exits the program, drops down to the prog_stop task, and runs whatever's in there. So that's why you see program start, which is this first one. Then you've got program loop, which is this one, and then you have exit prog run, which gives you bye, which is this guy here. So what we're going to do now is, instead of just doing this, because that's not very fun, we want to create a task that will flash all of the user LEDs on the JackBord. So if on your JackBord now, if you run the tgl command, all of the user LEDs will turn on, and then if you run it again, they should turn off. So it toggles the state of the user LEDs. So what we're going to do is we're going to write a user task called, wait for it, flash user LEDs, sh, user LEDs, Now notice what happens when I put a space and an equals. It turns blue, and that's because the editors realize that this is going to be a user task, so it is going to change the color of the text to blue. And then I want to finish the task by again using its name at the end followed by a full stop. So that's my user task. So I want to toggle the user LEDs on, then I'm going to wait, say 500 milliseconds, sorry, 500, and then I'm going to toggle them off, so I'm going to toggle them again, and I'm going to delay another 500 milliseconds, and then I'm going to toggle them again, and then I'll wait another half second. So I've got my user task called flash_user_LEDs. First thing I do is toggle them on, wait half a second, then toggle them off, wait half a second, and then toggle them back on and wait half a second. And then when I get to here, I'll return to wherever I called my user task from. So what I'm going to do is I'm going to call it from here. So I'll put a comment on that says flash user LEDs. And then I'm going to put the name of my task, which is flash user LEDs. And that's the call to my user task. So if I save this now, it's all fine. Now, I will run the program. Oh, it's already running it, so I saved it and ran it. And essentially what it's doing is it's flashing. So if I show you the JackBord, you can see it's flashing the user LEDs. And that's what it's doing. So you can see it's also printing over here. It's printing the prog loop message, which is this part here. So essentially we're running through the loop. It prints the message, then it comes down, sees my user task, drops down to here and runs these. And then as soon as it exits, it jumps right back up to the top, gets to here and goes back up to the top of the program loop and prints this again. So this is a user task. Okay, we're back with the program that we were just working on, and what we're going to do is we're going to add a new task called Jack. So when I type in Jack and then I follow it with an equals, what I'm doing is I am declaring this task. I'm telling Octagon that there's this thing called Jack and I want it to be a task. So that's what we've just done. And now what I'm doing is I'm putting Jack with a full stop, and that is telling Octagon that this is the end of the task Jack. So this is the declaration which says I want to create a task and I want it to be called Jack, and this is the beginning of it. And this is telling Octagon that I'm finished with the task Jack and I want this to be the end of that task. And then all the stuff that I put in the middle is the code that I want Octagon to run when I call that task. So in this case I'm going to get it to print hello Jack. Okay, and that's all that task is going to do. So if I put this task here underneath flash user LEDs, so now what we have is once it's finished flashing the user LEDs, it will run the task called Jack, and the task called Jack is going to print hello Jack. So let's run it and see what happens. And sure enough, there it is, hello Jack. So it flashes the LEDs like this. So if you look here, it's flashing the LEDs and then it's saying hello Jack. So it's running the two tasks. And then to stop the program, I'm going to click on the stop button. So that's an introduction to user tasks. And just to recap, things like prog start, prog loop, prog vars, and also prog stop, like that one there, are Octagon system tasks, and you can't declare those and you don't call them, they're just there inside Octagon. A user task is a task that you create as a programmer, you create it, and an example of course is the Jack task here and the flash user LEDs task. And this is where you put your own code into your own task and you can then call it. Okay, here's a little trick that you can do in Octagon. So as before, we've got the same program. If I run it, you see it will flash the lights and it says hello Jack. Okay, so now I'm going to stop it. I'll just clear the print tab. Now, if I remove the call to Jack, so I'm no longer calling the Jack task, if I run it again, notice how it's not calling the Jack task because we have taken that call out. But if you click down here and open up the command line, and then at the command prompt you type Jack, and you have to do this while the program's running, it executes the task. So effectively, the task has become a command line command. And that can be useful sometimes for testing, etc. So what we've done is with Octagon, when a program is running, a user task can be run from inside a program, which is normal, but you can also run it from the command line. For more information, visit jb.works.